Okay. Nothing special is really special. Okay. Life changes, but there is nothing changed for you. So it's pretty special. But anyway, I think Singapore is going to
June 1st, right?
relax their measures. Yeah, we are getting better daily.
Yeah.
So hopefully we will get to see each other face to face soon. Yeah. Okay. We should be doing the integration, right?
Mm-hmm.
Okay. Let me. I'm not sharing yet. Let me go and get your textbook out. Michael. Okay. Let me get your textbook out first. By the way, Warren Buffett is going to broadcast his annual shareholder meeting later, live. If you're interested, you can just go to YouTube and then just watch. Okay, so it's live for, I think, more than 5 hours. If you watch, just go ahead and do so. Okay, let me share my screen. Okay, so you should be able to see my screen now.
Yeah.
Okay, good. So we should be doing okay, I remember we did this question 9. Okay, remember question 9, and then we are asked to show this, and then I have shown you how to do it by partial fraction, or I have shown you how to combine the right hand side here into a single fraction. So basically, I have shown 2 ways to show this, and then with that, then we can integrate this definite integral from 3 to 5. Okay.
Right.
Now let's look at question 10. Okay, let's look at question 10 together. Let me get it into let me get this question 10 onto a blank page. Okay, here we are. Okay, so over here, given the right hand side, okay, and you are asked to find what is the lower limit. Okay, so by the way, this is the lower limit, or sometimes it's called the lower bound.
Yeah.
Okay, and then this is called the upper limit, or the upper limit, or it's called the upper bound. I'm sharing, right? Can you see?
Yeah.
Okay, just want to make sure I'm sharing my screen. Okay, so what it means graphically is this. So if you have a curve, okay, this is your function. Okay, so if you want to integrate from this a to b, so if you are asked to integrate your function fx from a to b, so what this integration means is you are actually finding the area under this curve, okay, bounded by a and b. Okay, so that's the meaning of it graphically. Okay, so this is actually you're finding the area of the shaded region. Okay, so okay, and the key concept is what? The key concept is it must be area under the curve. Okay, under the curve. Okay, what it means is it must be under the curve, which is here. Okay, it's not above. Okay, nothing to do with anything above. Okay, it's under the curve. Okay, so remember this. The key concept is the area under the curve and bounded by A and B. Okay, so A being the lower bound, B being the upper bound. Okay, so now this question, let me get it to the next page. So with the understanding, so right now what we are given here is we are actually given the area, or I mean, we are basically given the area under the curve already.
Okay.
Right? We are
Yeah.
given the area under the curve, which is ln 2/2. Okay? And now we are asked to find what is the lower bound. Okay? So what this means is, let me demo 10A first. Okay? So what it means is, what you need to do is you need to integrate this first. Okay? So to integrate this, what you need to do is, there is this special differentiation. If you differentiate ln x, you are going to get 1 over x. Okay? So you differentiate ln x, you get 1 over x. So this is 1 over 4 minus x, right? So therefore, if you go from here to here, that means if you integrate 1 over x with respect to x, you get ln x. So I'm actually making use of this rule. So what I will get here is I will get ln 4 minus x. And I know that when I differentiate this thing, I will get the -1 out, right? So I need to cancel the effect of my -1.
Yeah.
Okay, so let me simplify this. So without the lower and the upper limit first, let me just integrate it first. So I will get minus ln 4 minus x. Okay, so now let's put in the limit. So what I will get is, I'm supposed to get -2 and m here. And now what I do is I need to put in the -2. So I'm supposed to get ln 4 minus -2. Okay, so I will get this answer minus this set of answer, 4 minus m. Right? Okay?
Yeah.
So what I do is I need to simplify it. So what do you get for here? So it's ln 4 plus 2 is 6. So now it's minus. So since you have minus and minus, so you get plus. So over here, you're supposed to get what? Ln 4 minus m. Yeah. So you're supposed to get this. Okay? So if this is your left-hand side, so basically your left-hand side is equal to this. Okay? So your right-hand side is equal to this, right? Right? So what you do right now is you just equate this. So let me delete this first, so I have more space. So minus ln 6 plus ln 4 minus m, you will get ln 2/2. Okay, am I right? And then with this, what you can do is you can actually switch place. You can actually switch place. So you can actually write the positive in front. Okay. What I did is I switch place, rearrange. Okay. I move this to the front. Okay. And then of course I move this minus ln 6 to the back. Okay. I just rearrange them, and it shouldn't change the value. Am I right?
Yeah.
Okay. So with this, what you need to do is, if you remember, you can actually use this. If you have ln A minus ln B, okay, you can actually use quotient rule. So it's ln A, okay, bracket A divided by B. So you can actually use this quotient rule from logarithm. So what you get is ln divided by 6. So you get ln 2/2. So can you see that if you compare the left-hand side and the right-hand side, what you get is actually these two highlighted in yellow is actually equate to each other. So with this, you have simplified it into a basic math. Okay, you can actually use cross multiplication and continue to solve for this question. So I don't have enough space. Let me get it to the next page. Okay, so you actually use cross multiplication. So 6 times 3 is 18. 2 times this is 8 minus 2m. So you continue to solve it. So 8. So you have this. I bring the 8 over, I get minus 8. So I'm left with minus 2m. So where is 10? So m is equal to minus 5. Okay? So that's how you get your lower bound. Okay? M equals to negative 5. Okay? So far so good?
Yeah.
Okay? So the key here is you have to get it into this format. Okay? And then you will simplify it into this part so that you can use basic math cross multiplication to solve for your m, which is the lower bound. Okay?
Yeah.
Yep. So that's about it. So I will pass this question to you. So I will let you try B. Okay. So please try B out. Okay. Do it on a piece of paper.
Okay. Let me get a piece of paper.
Yeah. Do it on a piece of paper, please. So once you are done, just WhatsApp over your solution to me. How's your progress?
I'm done.
Oh,
Just sent.
okay, good. Let me check it out. Nice. Okay, looking at it. So, okay, you have found that m equals 2. Okay, so instead of using this method, I'm going to use another method, okay, to see if your answer is correct. So another method is, let me solve it by graph. Okay.
Okay.
How I'm going to do it is, so first let me draw this. Let me draw the 2x minus 1 out. Okay, let me establish a table first. So I have my x and my y. When x equals 0, your y is minus 1. And then when x equals to 1, your y is equal to 1. Yes. Okay, so with this, I can achieve. So 0 and minus 1, somewhere here. 1 and 1, somewhere here. Okay, so this is 0, this is 1, this is 2, and here's minus 1, this is minus 2. Okay, so with this, I can achieve. Okay, so basically this is my 2x minus 1, right? So now, you are asked to find from m to 2m, and then you are supposed to get 4 for the area under the curve. Okay, so you can see that under the curve, you can see that looks like I can't do it graphically. I just realized. Okay, so I must use your method. Okay, but let me check your answer. The m is 2, right? So m is 2. So it means from here onwards. So the lower bound is 2, right?
Yeah.
The upper bound is 4, right? Okay. Given that m equals 2, so 2m equals to 4. So what this question means is you are finding the area under the curve from 2 to 4. So let me extend this. So 3 and 4. Okay. So
yeah.
Let me extend this. So the curve is 2x minus 1. So your lower bound is 2, and then your upper bound is 4. So you're actually finding the area under the curve. So what I'm going to do is I need to find the area of this. Is a trapezium, right?
Yeah.
Okay. So the area of trapezium is, this is what's this and what's this? Okay, which you need to find out. Okay, so it's very easy to find out. So when the x is 2, so the y is actually 3, right?
Yeah.
So this is 3. So when x is 4, so the y is 7. So this is 7. Okay, so that means this top side is actually 3, and the bottom side is actually 7. So you times the height, which is 2, right? And then times half. So seems like something is not quite right then. Okay, so given this, so the is unit square, right?
Right.
So it looks like, given that if this is the 2 and this is 4, and the answer is 10. So instead of 4, right? So doesn't seem quite right, by graph. So let me check with the normal integration method. Okay, together. Okay, so first thing first, this is the left hand side. So what I do is I integrate this first. Okay, so I should get 2 power plus 1, and then bring down the power, and then over here you get x. Yep. So this is the So this is the integration. So you get x squared minus x. So 2m square minus 2m. That's your first value. And then over here, this is m squared minus m. So this will be your second value. Okay. So you will end up with a quadratic equations. This part you will get 4m squared minus 2m minus m squared plus m. Okay. So what do you get? This part and this part you get 3m squared minus 2m plus m. You will get minus m. So you will end up with, this is m, and then just leave it like this. This is the left hand side, and then your right hand side is 4. So basically this 3m squared minus m is equal to 4. So you bring the 4 over. So basically you get a quadratic equations. Okay, so you can use the factorization method, and you should get 1, 3 minus 4 and 1. So you should get m plus 1, 3m minus 4. Yes, so your m is supposed to be minus 1, or m is supposed to be 1 1/3. Okay, am I right? Am I right?
Yeah, okay.
Yeah. Okay. Okay. First thing first, let me check your answer. It doesn't seem right, because for your integration, what you do is, so for this definite integral, right? You can't do this. You can't say, oh, I get this. So what you did here is you are basically doing this. So with this, you just put in your what you do here is this. This is what you did, right? Yeah. You basically you are saying, when you integrate this thing, you will get this. That's not right.
Right, okay.
Okay. So what you are supposed to do is, you should integrate this first. Okay. So you should integrate this, which you get this, right? Then after that, you put in the upper bound and the lower bound. Okay. So this is not right. Okay. So you are supposed to do this. Then you will get your this m equals to -1, or m equals to 1/3. Okay.
Yeah.
And yeah, so then you get two sets of answer for this question. Okay, that's the reason why I try to use your answer, and I try to use the by graph, and then it doesn't seem right, right?
Okay.
Okay, so remember, to do this definite integral, so this method is not right. Okay, so let's do one more question, just to make sure that you understand how to do definite integral. Okay, let's do one more. Let's evaluate the following integral using area interpretation. So this part, let's do one more. So let's try this. Okay, so basically, you are integrating this from this. This whole thing is actually equals to this. Okay, try this out. Hit my. Okay, try this out. So you integrate this part first. Okay, so you integrate this part first. Okay, let me go and use the washroom and come back. Okay, I'm back.
Yeah, I forgot how to do the integration part.
Okay, so let's do it together. Then, so for this part, right? Your this 4, okay. For this 4, you will get, you're supposed to get 4x, right?
Yeah.
Okay, then for this part, we just did a similar question. So remember this, you differentiate ln x, you will get 1 over x, right?
Yeah.
So if you integrate 1 over x, you will get ln x. So I'm making use of this. thing. So I can actually split. I can split this to 5 times 1 over x minus 1, right? So what I do is, I will get, so basically what you do is you integrate this thing. Okay? You integrate this. So when you integrate this, you can actually put your 5 out. Because 5 is a constant. So when you integrate this, what you get is, you get ln x minus 1. Right? That's it. So plus a c. If there is no, plus a c, because it's an indefinite integral. Am I right? Yeah, Michael, am I right?
Yeah.
So therefore, for this, I will get 5 ln x minus 1. Okay. By the way, I know that the question give me a upper bound and lower bound, right? So now I just put in my upper bound and lower bound. So basically, you integrate 4, you get 4x. Okay, and then you integrate this 5 over x minus 1, you should get this. Okay, and now you go and insert the upper bound and lower bound. Okay, now you put in the 5 first. So you put in 5. Okay, this will give you 1 value, and then you minus, you input the 3 into it. Okay, so what do you get here? 4 times 5, 20, plus 5 ln 4. This is 1 value, minus 12 plus 5 ln 2. Am I right? So from here onwards, what you can do is you can go ahead and open the brackets. Okay, so 20 minus 12, 8. And then you have your this, right? So you take out the common factor 5. So you have ln 4 minus ln 2, right? And then ln 4 minus ln 2, you use the quotient rule. Okay, let me erase here first. Use the quotient rule, you should get 8 plus 5. The quotient rule says 4 over 2. So therefore, this is 2. So that's the answer. Okay? So this is the answer. So you are supposed to get 8 plus 5 ln 2. So the answer asks you to 8 plus 5 ln 2. Okay? Yep. All right. All right, Michael. Hello. Hello, Michael.
Yeah.
Yep. All right. Okay. Let's move on to question 11. So question 11 is making use of the curve or the graph. Okay, let's work on it together. Okay, let's try out A first. So A means you have your fx, which is given by this, okay? And then from the lower bound is 0, which is here. And then the upper bound is 3, which is here. And you are asked to find the area under the curve. So what is the area here? That's what you need to find out. Okay? So what is the area under this curve? So how do you figure out this? So what you do is, the area under the curve is this part.
Yeah.
Okay. So what you do, you can actually do this. Okay. So what you identify is you identify a trapezium, region 1, and then you also identify another trapezium, region 2. Okay.
Okay.
Right.
Yeah.
So for your this trapezium 1, okay, the area of your this one is the top is 1, okay, below is how much? Okay, looks like this one. Hello. Looks like this part is not quite clear, so seems like it's better for us to use another way to look at this question, because I'm not quite sure what is the length of this. Is not exactly half, right? Can you see? It's not.
Right, no.
So that's the reason why I can't break it down to this 1 and 2. I think the better 1 and 2 to choose is this. This is your 1 and then this is your 2. Okay. So the area of region 1 in this case is, so here is 1, very clear cut. Below is 3, very clear cut. And the height is what? 2. So you half it, and then you get 4 units squared. Okay. This is your region 1. And then region 2. The base is 1. The height is 3. And then you just half it. This is pretty clear. So this is 1.5 units squared. Okay. So region 1 add with region 2. That will give you the area under the curve for part A. Okay. So this is the answer for part A. Right?
Yeah.
Make sense?
Yeah.
Okay, which is this. Okay, now I will leave it to you. Pass on to you. Yeah, try out C. So try out C.
C.
Yes.
Okay. 4 to 2.
2 to 4. I will say 2 to 4.
2 to 4.
Yeah, try it out on a piece of paper. Let me get it to the next page so that it's easier for you to see it. Yeah. Try out C. So how do you find this? Okay, very good. So what you do is this will be your lower bound. This will be upper bound, right? So what you need to do, your region 1 and 2. By the way, your region 1 and 2 is the same. So once you find your region 1, so you just times 2, right? So
Yeah.
I found the region 1 just now already. And yep, so region 1 is actually the 2 here. So it's 1.5. Yep, so it's 1.5 times 2. So it's supposed to get 3 unit square. Okay? Good.
Yeah.
Okay. By the way, it's unit square because the over here is area. So area is unit square. Okay? Instead of unit. Okay? Alright?
Yeah.
So unit is for length. Okay? Unit square is for area. Okay? So bear in mind. So I'm talking about the unit. Okay? Okay, good. So then what about D? What about D?
D.
Yes. How do you find D? So to find D, what you do is actually we already found this already, right?
Yeah.
Right? We already found 0 to 3 already, right? And then we have found this part already,
Yes.
right? So the rest is what? The rest is basically
There's 3 and then 2.5 and then 2.
4, 5, 6, 7. Okay, 7.5.
Yeah.
Right? Yeah. By the way, you can actually, yeah, so this is 1 unit, right? Yeah. So you just count, so this is unit square for this part.
Yeah.
For this part. Okay? Yeah. So basically what you do is, this is the yellow part. Okay? So you add with this part, which is 1.5, right? We found it already just now. And then this part is let me check. This part is 5.5. Yeah, we found earlier. Okay.
Yeah.
Okay. So this question, it shows if you need to find this from 0 to 7, what you can actually do is you can actually break it down to 0 to 3 fx.
Yeah.
Plus 3 to 4 fx plus 4 to 7 fx.
Right.
Okay. So this is equal to 0 to 7 fx dx. Okay. Can you see that? The lower bound to the upper bound, and then this upper bound is, that means the next integration is start from the upper bound. Okay. So it start from the upper bound. Okay.
Yeah.
Yeah. So
Okay.
if you do this, you're actually finding this. Okay. Okay. So very simple question. Okay. Let's move on. Okay. Question 12 is similar. Okay. But for question 12, I think you have 2 semicircles, and then you have 1 square. Okay. But the technique is the same. Area under the curve. Okay. So I'm going to go through this because 11 and 12, they are similar. Okay. Now, yeah, over here, 13. Basically, we are making use of what we have learned just now. For 13, we're actually using what we have learned just now.
Right.
Okay. What I mean is, if you integrate 2 to 4 and then 4 to 7, what you can do is,
It's 7 to 2. Right?
yeah, 2 to 7.
Yeah.
Yeah. So this is what I mean by this upper bound is the lower bound of the next integration. Okay. You can actually combine them. Okay. So similarly, this upper bound is the lower bound of the next integration. This upper bound is the lower bound of the next integration. So therefore, you can actually combine. Okay. So you get a single integral. Okay, so very simple. So if you can actually convert it to this, that means this back to this is also correct. So
No.
this is, you combine it into a single integral. So this is, you combine them into a single integral. So this one is, you break it down. Okay, so both ways work. Let's move on. 14. Okay, so 14, let's try out 14, making use of the what we learned just now. Okay, let's try out just part B. Okay, try out part B.
Wait, what? B.
Part B, 14B. So first thing first, what you do first?
Wait, 3, 4, 4, 2, X.
So once you are done, just WhatsApp me. Yeah.
X is, was it 5? Four?
Okay, so I am not sure, but let's do it together. So over here, what I see is from if you integrate your fx from 0 to 2, okay, you get 5. So
Yeah.
let's do it practically. So this is my fx. This is my fx. Okay. If I integrate from 0 to 2, so this means this part is 5 units squared, right? And now 4 to 6. 4 to 6 is this part, right?
Yeah.
And looks like this part is -2.
-2, yeah.
Which means is below the, x-axis. Okay, below the x-axis. So it means this graph is not right. Okay, but so 4 to 6 should be below. Okay, but if you absolute it, right? If you absolute it, it should be 2 units. Okay, that's the meaning of it. Okay, now therefore 0 to 6 is 7. Okay, so 0 to 6 is 7. So means here to here is 7. So what you do is you can actually rearrange this plus 2 to 4 plus 4 to 6. And then what do you get for this? So I know that this one will give me 5. This one is what I need to find, right? And then 4 to 6 is minus 2, right? And then 0 to 6 is 7, right? So you are asked to find the question mark. Am I right?
Yeah, it's just 4.
Is it 4? Okay.
Yeah,
let's
it's 4.
together. Yeah, so 5 plus question mark, which is x. So minus 2 is 7. So 5 plus x is 9. Yeah, so x equals to 4. Okay? Yeah, the answer is correct. Okay? Good. It's 4 units. Yeah, the value is 4. Okay? Let's move on. Yeah, let's try 15. That's the last question of this. Let's try 15. Okay, let me just caution you about this. So you can see, right, this one, the value is -4. Okay.
Yeah.
If they ask you what is the area of this, it will be 4 units square. Okay. The reason is the value can be negative here. Okay.
Yeah.
Okay. The value can be negative. But when it comes to area, right? Area is not a vector. Area is a scalar, right? So scalar cannot be negative. So therefore, if they ask you for the area, it has to be a positive number. That's why it has to be 4 units squared. Okay? So if they ask you for the area, it has to be positive 4. If they ask you for the value, this one is the value, right?
Yeah.
It can be a negative number. Okay? So please differentiate between value of this thing, this integration, and area of this integration. Area has to be positive. Value can be negative. Okay? Okay? Good.
Okay.
So with this understanding, try out 15. Or we can take a break first.
Okay.
Okay? Let's take a 5-minute break, come back, and we will
Yeah.
take a look at this question.
Okay.
Okay? Yep. So I will mute myself plus the video. Okay, I'm back. If you are back, just let me know. 乜嘢啦？開始啦。I'm back 啊。Let me know when you are back, Michael. Okay, next time. Certainly. No, I mean audio and video. Suddenly someone passed by with
Hey, I'm back.
now I can see your chest and above. Just now I only see your eye level.
Oh, yes.
I mean I wish to see more of you, okay?
Oh,
Great. Okay. So yeah. So let's try out this question 15.
ugh. Oh, I need to talk to my mom about something real quick.
Right now? You mean right now? Okay, go ahead.
Okay. I'm back. She was about to order dinner.
Okay.
So
Okay. Okay. Yeah, let's try out this question. Let's try out the ABCD. So what are you planning to eat for dinner?
Burger King.
Oh, okay. Order from outside.
They have this like good Swiss mushroom burger.
Okay.
It's like stack and it's got a lot of meat.
Yeah.
So
By the way, these days you can upsize to really.
no, you upsize the sides. I don't like the sides. They're like Burger King's fries are terrible.
But Burger Kings, you can upsize the burger, right?
Well, you only get two patties and that's it.
Okay.
Was it A? A is still -4, right?
If you switch place, I think you should get 4.
+4? Does it make a difference?
All right, let's test it with simple fx. So I mean, just let fx be 2x. Okay. Okay. So if fx is 2x, so wait, I can't do it. But okay, let's draw it out. So Negative 4 means from your -1 to 1. So basically you get -4. The reason is you have more negative region than positive region. That's what it means. Then positive region. That's why you get -4 for the value.
Yeah.
Okay. So yeah, more negative region. Okay. So now you switch place. So that means instead of from here to here, so now you go from here to here. Okay. So if you look at the, let's look at this. Let's look at this. The properties of integration. Let me see where it is. Over here. Can you see this?
Yeah.
Yeah. So if you have your A and B, right? Lower bound A and B, lower bound A, upper bound B. If you flip it, right? If you flip it, so it means you need to put negative in front.
Yeah.
Yeah. So that's the reason why. That's the reason why you should get. That means I'm using this. Let's go back to the slide. So let me clear this. So I'm using this. Okay. So you flip the range. Okay. So once you flip the range, here, right?
Yeah.
So you are supposed to have a negative in front. So that means this will give you a 4. Right?
Yeah.
Yeah. So A is 4. Okay. Continue with B. So which part you are doing?
I have. Second. What? At 0. Is it? I don't know.
You mean part 15b, boy?
B.
Okay, let's work it out together. So for this, you can actually do this. Okay, you can actually you can integrate term by term. All right. So this is given by the question, right? So how do you integrate this? So you get 2x, right? Okay. So basically, you just have to solve this, right? So put in 1, so you get 2 minus 2. Okay, so 4 minus 4, yeah, you get 0, correct? Okay, so the value is 0. Okay, very good. So this is equal to 0.
Right.
Continue.
Okay, 0. Yeah, okay. I was right.
Yeah, correct.
And the next is just times 2, right?
Exactly. So it's negative.
Yeah.
So you get, so this is given, right? So you get negative 8, right? Okay. So last but not least, what about this?
KF equals to 7. But 7. Okay, such that. Okay, 7 divided by.
So you can take out the k, right?
It's negative 1.75.
Yeah, something like this.
Yeah.
You take out the k, so this is given negative 4. Okay, so k, right?
Yeah.
Yeah. Okay. Pretty simple. Okay, let's move on. Let me close some of the windows first. Okay. Yeah, so we have come to the review sessions. Oh, who's this? Okay. Bernhard Riemann. Probably is a German.
Yeah.
Yeah.
Probably.
Okay, because I remember Lehmann,
Yeah.
the goalkeeper of Germany. Okay, so yes, so this is about the so if this fx is bigger than 0 on the integral, so we have seen that the area under the curve is, yeah, so over here, so this is known as the Riemann integral. Okay, so area under the curve. So this part we have done it just now, area under the curve. So with range we have done this already. So now let's take a look at question 2. Okay, let's try A and then C. Okay, let's try it out. By the way, for differentiation of trigo, you can make use of this. So it's always a good practice to write this down before you attempt to do integration or differentiation. Yeah. Okay.
Okay.
And then EX, and then you get EX. And then ln X, you get 1 over X. Yeah.
Okay.
So once you are done, just WhatsApp over.
Okay.
So, all right. Is everything okay?
Yeah.
Good. Okay. Are you done?
Almost.
Nice. Okay, can we go through? Can we go through together?
Yeah.
Okay, let's go through together. So for this, what you can do is you can change this to negative index. Okay, so once you have this, so take out the constant 4. So all you need to do is you integrate this part. Okay, so power plus 1, and then bring down the power to the denominator, which is half, right? So this is an indefinite integral, so therefore you get a plus c. So simplify it further, you should get 8x to about half plus c. Okay.
Okay.
So that is the answer for part A. Now this part, I'm using this, or no, I should be using the second one. Okay, I should be using the second one. So if you integrate, so here to here is integration. You integrate minus sine x, you should get cosine x, right? So you integrate sine, so you should get minus cosine 4x minus 5. And you know that when you differentiate your cosine, bracket 4x minus 5, this 4 will be taken out. So you need to have a 1/4 to cancel the effect of that. Okay, so since this is an indefinite integral, so there is no lower bound and upper bound, there's no, so therefore you need to plus a constant c. So if you combine this, okay, so you should get this. Okay, so that's it. Okay, very simple. Okay.
Okay.
Okay, so let's move on. Okay, exact value, which is the definite integral. Okay, let's try out A. Okay, let's try out A. Ready, Michael?
Yeah.
Yeah, let's try out A on your side. Okay, that's question A.
Okay.
All right.
So question A, I got 2/3 minus square root of 126.
Okay, fine. So let's go through it together and compare my answer with your answer and see whether you are correct or not. Okay. So to integrate this, okay. So this is a definite integral, which means you have a range. Okay, you have a range. Okay, so the range is given by this. Okay, the lower bound and then the upper bound. So before you do that, you integrate whatever is inside first. Okay, you change it to a positive index. Okay, you integrate this first. So what you get is you use chain rule, right? So power plus 1, and then bring down the power. Okay, and you know that when you differentiate, this -3 will be taken out. So you need to cancel the effect of -3, right?
Yeah.
Okay, so that's all. Okay.
Okay.
Now, pardon?
Oh no.
Now then now you can actually input the range into this. Okay, but before I input it, of course, I want to tidy up this thing first. Okay, so let me tidy up. So you have a -3, 1/-3. So 1/-3, right? Okay, so you're supposed to get 2 is still on top, and then 3 times -3 is -9. Okay. So you can now input this -1 and -5 into it. So I'm going to use the next page. Okay. So just input the value, and then you're supposed to get 2/3. Okay. Then you get one set of value, and then find out another set of value when -5 is sub in. Okay. So for this, you are supposed to get this. So 1 minus -3 is 4, right? Okay. Then over here, you should get -15, so it's 16. Okay. So pretty simple right now. So this is 2 to the power of 2, right? So this thing will give you 2 to the power of 2, and then you have 2 times to the power of this. So you get to the power 3, which is 8. Then what do you get here? You get so this is 4 to the power 2. So you get 4 to the power 3, which is 64. Okay, so just simplify this. So you get 128. Okay, so you just minus. So take this minus this. Okay, so what do you get after that? So of course you can use a calculator. Okay, then you don't have to do so much work if you use calculator. You just punch your calculator, and you should be able to get your answer very quickly instead of doing so much steps. Okay, I don't have a calculator with me, so I just try to do it mentally. Okay, so you're supposed to get 128 minus 16 is 112 over 9. Okay, so 122, 2. Okay, yeah, this is supposed to be the answer. Okay,
Okay.
yeah, so far so good. Oh, you're too far away from your computer. Yeah, can't really hear you. Okay, so you're supposed to get this. Okay.
Yeah, okay.
Good. Let's move on. This part. Let's go to the part B together. Part B is actually even simpler. So remember this. You differentiate your sine x, you get cosine x, right? So therefore, what you do is, if you integrate this cosine pi over 2, or it's x, it's not pi. So it's half x. Okay, so you are supposed to get sine half x. And you know that when you differentiate this, when you differentiate your half, when you differentiate this thing, half will be taken out, right? So you need to counter the effect of it. Okay, that's all. So then you just key in just input the range. Okay, so very simple. Sine half times pi over 2. This will be one answer, minus of. So sub in your value of 0. So you get another answer. So
Right.
sine 0 is 0. So basically this will give you 0. And then over here, pi over 4. So pi over 4 is actually 45 degrees. Okay. So sine 45 is how much? Sine 45 is how much? You can actually use this special angle, right?
Yeah.
So this is 1, this is 1, this is square root 2. Okay. So sine 45 is O over H. Okay. So O is 1, H is this. So O over H. So what you get is this. Okay. So this is the exact value, right? They're asking for exact value. Can you see? Okay. So that's why you're supposed to give in this manner. Of course, once you get 2 over square root 2, right, you can actually rationalize it. Okay, you can actually rationalize it. So after rationalization, this should be your answer. Okay.
Okay.
So this is after rationalization. Okay. So this is after rationalization. After rationalization. Okay. This is before. This answer is before rationalization. Okay, both are acceptable. Okay, but it's a good practice to express it in after rationalization. Okay.
Yeah.
Okay. Hey, let me see. No, it should be square root 2. I just make a mistake. The reason is you are supposed to get this, right? After rationalization, you're supposed to get this, right? So you cancel this, so you are square root 2. Okay. Okay, so this is the answer after rationalization. Okay, before rationalization is this. So this one is before rationalization. Okay, this one is after rationalization. Okay, all right.
Yeah.
Okay. By the way, you must be wondering why this is 45 degrees, because pi is actually equals to 180 degrees. So that's how I get 45 degrees. Okay.
Okay.
Okay. So yeah. So let's see. Let's go back to your textbook. Yeah, we stop at here. So yeah, next lesson we will continue to sweep through the rest of the questions. Okay. So this one is without calculators. So from here onwards is you can use the calculator. Okay. So
Oh,
yeah. So any other question for me?
no.
Okay. So if not, then I will call it a day. So thank you for your cooperation. So that's
All
it.
right. I'll see you next week.
Yep. See you next week. Okay. Okay. Thank you so much.
Bye-bye.
Let me see.